Hi, I have this garage opener and I have this remote here with three buttons on it. Um, I want to have the second button on the remote turn on these rear ceiling lights. They're really bright, and the tiny light on the Liftmaster is not that bright. There are two wall switches which turn on the ceiling lights, and I want those to keep working the way that they do, but have the remote button override the wall switches. I've actually found surprisingly little documentation on how to do this, so after some digging around, I'm making this video to share my approach and what I learned. And I think anyone with some basic home electrical experience will be able to follow this, but definitely if you don't feel comfortable working on electrical, best to call an electrician. So the first thing I need is a way to translate my remote's button number 2 here into an electrical signal. Some openers apparently have auxiliary terminals. Unfortunately, mine does not, so I need an external receiver module to pick up that signal from the button number 2. I got this Liftmaster 850LM. You can check your remote model and just make sure that you get a receiver module that's compatible with the remote that you have. This one should work okay. And according to the instructions, to program this, I press Learn on the receiver and then hold the remote button until the LED blinks on and off for the channel I want. So let's give it a try. Press the Learn button here. Hold the remote button, and that seems to have worked. Put some contact leads on here, and this is a normally open side, so let's see. So what's interesting is, as I press the button on the remote, this turns on and off real quick, momentary. It's not a latching circuit. It doesn't turn on and stay on and then turn off and stay off, which is what we'll need if we're going to power some lights and have them stay on. So we'll have to do a little more digging and figure out what other component we need in our circuit. So turning the lights on and off will require a circuit that latches on and off, but the receiver outputs a momentary signal like a doorbell button push. So I need to add a flip-flop relay after my receiver. These are pretty cheap. I got this one on eBay for about $7. It's just a one relay flip-flop circuit. It says Electex up on the bottom of it. 12 volts DC in and a trigger, low trigger, and then there's the typical relay outputs on the side. So of course here's my receiver. I can use the 12 volts from the power supply to power the flip-flop relay too. Then I'll connect the negative to the receiver common terminal and normally open from the receiver to the flip-flop trigger terminal. When the flip-flop trigger pin sees negative or low, it toggles from off to on or on to off. So let's give it a try. I got my voltage here. This is power supply. The white wire is positive. So I'll put this in here. Negative is going to go in here. Now I actually have a couple things to tie to the negative, so I'm just going to use this jumper here I made and tie the negative terminal, connect that to the common of channel 1. Okay. Now I have my relay here on the back. There's all these prints. You see VCC, GND, and T. I've got the wires color coded on it, but red is plus voltage, black is ground, and then the blue I've got is the trigger. So we'll start with the red. We can hook that into the same terminal as the positive voltage for the receiver. We'll take the negative, and actually you could either put it to the negative here or this common. They're both the same connection. It's just connecting it to the negative voltage of the power supply. And my trigger, I'm going to hook this to the NO. This is normally open, so when you hit the remote, it's going to momentarily connect common and NO. So I think that's connected. So let's go ahead and plug this in and give it a try. See if I can hold on to this here. All right. So as you can see on my meter, if I press the button, it turns on and stays on. Press my button again, it goes off and stays off. So I think we have a winner. Now we're not out of the woods yet. We've still got to connect this to the power relay that's going to actually power the lights, or connect the lights to this flip-flop relay in some way. But this is a significant move forward. So I made a schematic of what I think will work. The receiver and flip-flop get a 12-volt DC power source, and the receiver, normally open, sends a negative signal to the flip-flop trigger here. Then the flip-flop relay, normally closed terminal, this one here, will get 120 hot input from the wall switches. The normally open terminal here will get 120 hot input from an unswitched outlet box. It's important that be on the same circuit breaker, so make sure you got that going. And the common terminal will output 120 hot to the lights. Keep in mind the electrical, home electrical, the hot wire is typically your black wire, so keep an eye out for that. So at rest, the flip-flop relay will leave the lights connected to the wall switches. When the flip-flop relay is triggered on, the relay will disconnect the lights from the wall switches and connect the lights to the 120 volts unswitched outlet source. So let's give this a try. Be sure you've shut the right breaker off for this next part. You want to make sure there's nothing hot, no voltage. I've installed an electrical box here in my attic of the garage, and I have the wires coming in for the wall switch, the lights, and constant 120 volts from an outlet. And this outlet here, I actually installed this for this effort. This is on the same breaker as my wall switches and my lights. It wouldn't be a good idea combining different breaker circuits. You want everything running off the same breaker circuit. Now, the first step here, I went ahead and tied all the grounds together. I'm going to tie my white, the neutral wires, together with a wire connector. So I'll get that started. One white wire, here's another white wire, here's another white wire. Okay. Wire connector here. I can put that on. Snug that up. And I usually just give it a tug, make sure none of the wires seem like they're loose or flopping around. Everything seems pretty tight, so that's good. Now, I've still got my 3 hot wires, the black wires. We're going to bring the flip-flop board now into the picture. And this is going to connect to the 3 black wires on the relay side. And then the logic side is going to connect to the receiver. And I did heat shrink this flip-flop circuit. That's not really too necessary. Electrical tape or something could work fine. I just wanted to make sure that the bottom of it with all the terminals isn't just exposed, because there are the ground wires in here. Just protects it a little bit better. So now the normally open connection, we want that to go to the output. Okay, that's good. Of our electrical box. So this is normally open to a constant 120 volt source. The flip-flop can toggle on. Here are the wall switches. So I can take this one, give this another wrap. This is going to go into normally closed, because by default we want the wall switches to work. Don't want them to be bypassed. Okay. All right. And lastly, the lights are going to connect to the COM, or common terminal, of our relay. We got a lot of wire on there. I think I'll snip some of that just to get rid of some of that excess wire. Real tight. Tight, tight, tight. Alright. So there we go. This is the flip-flop circuit. And then the logic for the flip-flop circuit I just have coming in through this cable I made. As you can see, it goes to the Liftmaster. This is the same circuit that we built before. It's wired exactly the same way. I have the 12 volt DC power supply. The particular receiver I have is pretty flexible. You got to look at your manual to see what it'll accept. But 12 volts DC will work fine on mine. And since that's what the flip-flop circuit expects as well, that's a pretty good thing. We can use the same voltage supply to drive both. I'll bring this in here and just make sure we have the right thing here. I've got trigger on the left, like that. Plug in there. Now I've got the plug plugged in. So this is about what it's going to look like. The next step will be putting everything in here so that it fits. Everything is put in place, and we can put the cover plate on But let's cut the power back on. And now with the flip-flop circuit in, it's connected to the receiver. We've got the receiver and the flip-flop circuit powered by 12 volts DC. The output relay for the flip-flop is connected to our hots on the lights, the wall switch, and the constant from the outlet box. Let's see what happens. So we'll start with the wall switch. Turn it on, turn off. We didn't break the wall switch. Now for the big test. The Liftmaster remote turns on and off the light. So button 2 will turn it on. It'll stay on. Press it again, it goes off and stays off. What if you have the wall switch on and you happen to press the remote button? You hear a click and it gives a little tiny flicker, but it doesn't do any harm. It's just connecting it, switching it between the hot leads. So there you have it. I think we have a winner. Now we just have to go in the attic and wrap things up, clean all the wires up, and put them in safely in the electrical box. So here's the electrical box in the attic again. I just kind of shoved all the wires in there. I made sure all these wire nuts are nice and tight. Here's the flip-flop circuit on the top. There's nothing really touching it. I went ahead and zip tied these 3 hots that go to it, the hot wires, just to be sure that those are as safe as possible. If they were to work themselves out of the flip-flop screw terminals, they can't go anywhere. They just hang up at the top. And the logic plug is on this side, so should all be good. I'm going to go ahead and put the cover on. I got this cover at the hardware store. Should be able to get this on here. That's not going anywhere. I think we're set. Yeah. Just make sure I hear a click. Everything seems to be working. I think we're fine. Hopefully this helps some people out there. I would have hoped to find this video when I was looking around, so hopefully this will help somebody else. And of course, you assume all liability for anything you do. And again, if you don't feel comfortable working on electrical at home, just call an electrician. Don't try to do it yourself if you don't feel comfortable. And good luck. If you do have success or attempt this project, I'd love to hear in the comments section. Just go ahead and post what you found. And hopefully this helps some people out. Have a good one.